Welcome to School of Joy. Today we're going to dive into something you use every day, whether you realize it or not.
Right.
Mathematical problem solving.
Yeah.
But we're not crunching numbers.
No.
We're going meta.
Yes.
With Alan Schoenfeld's work from his 1985 book, Mathematical Problem Solving.
It's a classic for a reason.
Absolutely. And think about it.
Yeah.
Understanding how we solve math problems helps us in every subject.
Right.
From writing essays to, well, even understanding deep dives like this one.
Absolutely.
So Schoenfeld gives us this really cool framework for breaking down how we tackle problems.
Yeah.
It's not about being good or bad at math,
Right.
but about these four areas: resources, heuristic control, and belief systems.
Think of it like equipping a children for a challenging hike.
Okay.
Resources are their backpack.
Okay.
The knowledge they're carrying.
Okay, so that's the facts, formulas, the building blocks of math.
Exactly.
Makes sense.
Yeah.
But what about these heuristics?
Heuristics.
It sounds kind of intimidating.
No, don't worry. It's simpler than it sounds.
Okay.
Heuristics are the strategies, the map and compass for our hike.
Okay.
They're things like drawing a diagram, breaking the problem down,
Right.
or even working backward from the answer.
So it's not just knowing the stuff, it's knowing how to use it.
Yes.
Which brings us to control, right?
Exactly. Control is like the hiker's stamina and pacing.
Okay.
It's their ability to plan the route check if they're on track, decide to switch tactics if needed.
Yeah.
Schoenfeld found that even students who knew a lot often struggled because their control was weak. They'd rush in without a plan and get lost.
It's making me think about all those times I panicked during a test and just blanked on the answer even though I'd studied. Which leads us to the most fascinating part, I think: belief systems.
Yeah, this is where things get really interesting
Yeah.
because it's not just about the hard skills of math. Belief systems are the hiker's mindset.
Okay.
Their confidence, their attitude towards the challenge. Do they believe they can reach the summit?
Right.
That effort matters more than just being naturally good.
So someone who thinks they're bad at math might not even try a difficult problem.
Yeah.
Their belief becomes a self-fulfilling prophecy.
Exactly.
Schoenfeld's book is packed with case studies
Yes.
where we see these ideas in action. He actually watched students solve problems like a teacher observing their class.
Yeah.
To see how these four elements play out.
And one that stands out is Renee,
Okay.
a college student working on a geometry proof. She had the knowledge, the resources, and knew some strategies, heuristics.
Okay.
But she got stuck.
Let me guess her control wasn't so great.
It was part of it.
Okay.
She had this fixed mindset that math problems should be solvable quickly. When her initial approach failed,
Yeah.
instead of analyzing why or trying something else,
Okay.
she got frustrated and gave up.
Oh.
Her belief in speed over strategy became a stumbling block.
It's making me think about how, as teachers,
Yeah.
we often focus on the what of math,
Right.
the contract, but maybe not enough on the how,
Yeah.
those metacognitive processes Schoenfeld emphasizes.
That's a great point.
Yeah.
Teaching students how to plan their approach, monitor their progress, even how to reframe negative self-talk could be as important as teaching them the Pythagorean theorem.
It's like giving them the tools and the instruction manual for using them.
Yeah,
Schoenfeld actually argues for making thinking visible in the classroom.
absolutely.
Okay.
If teachers model their own problem solving out loud, including when they get stuck or make mistakes, students see it's not about instant brilliance,
Yeah.
but a process anyone can learn.
Which takes us back to belief systems. If students see struggling as normal, even valuable, that changes the whole game.
Right.
Okay, so we've got these four elements.
Yeah.
But how do they actually interact?
Right.
I'm picturing a big tangled mess.
It is interconnected,
Okay.
but not a mess.
Okay.
Think about it.
Mhm.
If a student believes they're bad at math, belief system,
Right.
they might not bother planning their approach,
Okay.
which then makes it harder to effectively use the strategy they know, even if they have the basic knowledge resource.
Wow, it's like a domino effect.
Yeah.
One negative belief can topple the whole problem-solving process.
But the good news is it works the other way, too.
Okay?
Focusing on any of these elements can strengthen the others.
Right.
Helping students see the value of planning control might boost their confidence belief system, which then leads them to try more strategies, heuristics. It's a positive cycle we can nurture as teachers.
This is blowing my mind.
Right.
It's not just about drilling math facts anymore.
No.
It's about understanding how our brains actually work when we're doing math.
And realizing how much power we have to improve those processes.
This makes me wonder about those domain-specific beliefs Schoenfeld talks about. The one specific to math?
Yes, like the one right way belief, where
Okay.
students think there's only one correct method to solve a problem. They get stuck memorizing procedures instead of understanding the concepts.
So they might freak out if a problem looks different from what they've memorized,
Right.
even if they could solve it with a different approach.
Exactly. Or the speed belief, where
Okay.
students think being good at math means solving things instantly.
Right.
This can lead to anxiety and rushing,
Yeah.
which often leads to mistakes.
Mm-hmm.
It can even make a classroom feel competitive in a way that hurts learning.
It reminds me of students who say, I just don't get it. 2 seconds after reading a problem,
Yeah,
patience and exploration are just as important as speed, especially for deep understanding.
absolutely. And Schoenfeld argues that teachers have a huge role in shaping these beliefs,
Right.
emphasizing understanding over just the answer,
Mm-hmm.
valuing different approaches, celebrating the process of struggle.
Right.
These can all help students develop more positive beliefs about math.
It's like we're setting the stage for their learning,
Yeah,
creating a classroom culture where it's safe to explore and make mistakes.
and where they see themselves as capable mathematicians, not just memorizers of formulas.
This is giving me so much to think about, not just for my students, but even for myself.
Mm-hmm.
Okay, so we've got these beliefs floating around,
Right.
but Schoenfeld gives us some really powerful examples of how they actually play out in student behavior, right?
Definitely one that comes to mind is John,
Okay.
a college student struggling in calculus.
Mm-hmm.
Even though his professor considered him bright,
Okay.
what Schoenfeld discovered was fascinating.
At all ears.
John had this deep-seated belief that he wasn't good at word problems,
Okay.
based on a bad experience in high school.
Oh,
Even years later, this belief was affecting him.
wow.
When faced with word problems, he wouldn't carefully read them, he'd just jump into calculations.
Oh, wow.
And he wouldn't seek help because he thought it confirmed his weakness.
So his belief was actually influencing his actions, even making him avoid behaviors that could help him improve.
Exactly.
It's like he was sabotaging himself without even realizing it.
Exactly. This highlights the power of belief systems. They don't just exist in our heads.
Right.
They drive our actions, which then reinforce the beliefs.
Wow.
But it also shows so crucial it is to identify and challenge those limiting beliefs.
Right.
What if John's teacher had helped him reframe that experience,
Mm-hmm.
showing him how to approach word problems strategically and emphasizing that struggle is part of learning?
His whole trajectory could have been different.
Exactly.
It really emphasizes that teachers aren't just teaching content, we're shaping mindsets.
Absolutely. Schoenfeld's work makes me think about teaching less like filling a bucket and more like planting a seed.
Mm-hmm.
We provide the right conditions, the nurturing environment, and then watch the students' understanding blossom.
This is such a great analogy.
Yeah,
It's not about force-feeding information,
right.
but giving students the tools and support they need to grow their own mathematical understanding.
And to see themselves as capable mathematicians, not just passive recipients of knowledge.
Speaking of resources, Schoenfeld digs deeper than just saying you know your stuff.
Uh-huh.
He explores how that knowledge is structured and used.
Yeah.
Let's unpack that a bit more.
He's got a point.
Okay.
Resources aren't just a jungle of facts in our mental backpacks. He talks about factual knowledge, knowing your times tables, for example.
Right.
Procedural knowledge.
Okay.
Being able to solve an equation step by step,
Right.
but also conceptual understanding.
So that's the deeper lie behind the math, right?
Exactly.
It's like I can follow the steps to break a cake,
Mm-hmm.
but understanding the chemistry of how ingredients interact makes me a better baker overall.
Exactly. And then Schoenfeld includes problem-solving strategies.
Okay.
Those heuristics we talked about as
Right.
part of our resources, too. He argues that having a diverse set of these strategies and knowing when to use them is crucial.
So it's like having different tools for different jobs.
Exactly.
You wouldn't use a hammer to screw in a light bulb.
Exactly. And as teachers, we need to help students build this toolbox of strategies,
Right.
but also guide them on when to use which tool effectively.
It's making me think about how we often teach one way to solve a problem.
Yeah,
But Schoenfeld is saying, no, let's give them multiple tools and the flexibility to choose.
that's a great way to put it.
Yeah.
It's not about memorizing one right way,
Right.
but developing that flexible problem-solving mindset.
Mm-hmm.
And it all comes back to control that ability to monitor your own thinking and make strategic choices about what approach to use.
Okay, so we've laid out Schoenfeld's framework and touched on some of his case studies.
Mm-hmm.
But I'm wondering, what are some concrete takeaways for teachers?
Yeah,
How can we apply this in our classrooms tomorrow?
that's a great question.
Yeah.
One big takeaway is the importance of making thinking visible. It's not enough to just demonstrate the right way to solve a problem. We need to model our own thought processes, including when we get stuck, make mistakes, or try different approaches.
So we're showing students that struggling is part of the process, not a sign of failure.
Exactly.
It's normalizing that feeling of, wait, I don't know what to do next.
Exactly. And when we verbalize our thinking, we're giving students a window into the expert's mind.
Right.
They see that problem solving isn't about magic or being smart. It's a set of skills they can learn too.
Which brings us back to those beliefs. If students see that even their teacher makes mistakes, it could be a powerful message that it's okay to make mistakes themselves.
Right.
It shifts that whole classroom culture.
I love that.
Yeah.
It's about creating a space where students feel safe to take risks,
Right.
try different approaches, and even revise their thinking along the way.
And it's not just about making our thinking visible, but helping students make their thinking visible too.
Yes, encouraging students to explain their reasoning, to articulate their strategies, even to simply talk through a problem out loud.
Right.
These can be incredibly powerful tools for developing metacognitive awareness.
It's like they're becoming their own coaches, learning to analyze and guide their own thinking. And we can help them develop that skill.
Absolutely. Another concrete takeaway is to incorporate more opportunities for reflection into our teaching.
Okay.
After solving a problem, it's not enough to just check the answer.
Right.
We need to encourage students to ask themselves, how did I approach this? What worked well? What didn't? What can I do differently next time?
It's like taking that post-hike analysis and applying it to math.
Exactly.
You wouldn't just finish a hike and never think about it again.
Right.
You'd think about what you learned, what gear worked, what you'd change next time.
Exactly. And by incorporating reflection into our math lessons, we're helping students develop that crucial control element, that ability to monitor and regulate their own thinking.
So instead of just being passive recipients of information, they become active problem solvers.
Right.
Thinking strategically and making intentional choices about their approach.
This all ties back to Schoenfeld's emphasis on nurturing the whole learner.
Right.
It's not just about the content. It's about the cognitive processes, the beliefs, the emotional responses. All these things work together to shape a student's mathematical journey.
This is such a powerful reminder for teachers. We're not just teaching math, we're shaping minds.
And that's a huge responsibility, but also an incredible opportunity. By understanding Schoenfeld's framework, we can create learning experiences that are more engaging, more effective, and ultimately more empowering for all students.
And wouldn't it be amazing if students left our classrooms not just knowing math, but loving to learn?
That's the dream, and I think Schoenfeld gives us a roadmap for how to get there.
This has been so insightful.
Yeah.
We've covered a lot of ground. But one of the most compelling points, I think, is the role of emotions in problem solving.
Absolutely.
It's not just about cold logic. Feelings are in the mix too, right?
Absolutely. Schoenfeld argues that affect those emotional responses play a huge role.
Yeah.
Think about it when a student feels anxious.
Yeah.
It can actually reduce their working memory, making it harder to think clearly.
It's like that brain freeze moment during a test, even if you know the material.
Exactly. But positive emotions,
Yeah.
like curiosity or excitement, can actually boost motivation and help students persevere.
Right.
Schoenfeld is saying we can't ignore the emotional side of learning.
So it's not just about creating a supportive learning environment.
Right.
It's about understanding how emotions can literally help or hinder the problem-solving process.
That's right. Teachers can help by presenting math in engaging ways, connecting it to real-world applications, or even incorporating games and puzzles.
Right.
But it's also about helping students manage their emotions.
Teaching them coping mechanisms for when they get frustrated.
Exactly.
Showing them it's okay to take a break and come back later. Normalizing those feelings instead of pretending they don't exist.
Exactly. And by acknowledging the emotional side of learning, we're validating the student's experience, showing them that we care about the whole person, not just their ability to get the right answer.
This is making me think about how we often praise students for being smart or talented, but maybe we should be praising their effort.
Yes.
Their resilience, their ability to regulate their emotions in the face of a tough problem.
That's a powerful shift.
Yeah.
It's about recognizing that those qualities, those habits of mind, are just as important, if not more so, than innate ability.
And by praising those qualities, we're encouraging students to develop them.
Exactly.
We're sending the message that these are skills they can learn and improve, which can have a huge impact on their belief system and their overall approach to learning.
This reminds me of another important aspect of Schoenfeld's work that we haven't touched on yet.
Okay.
The difference between inert knowledge and active knowledge.
Okay, I'm intrigued. What's the difference?
Inert knowledge is stuff we might be able to recall or recognize, but can't actually use effectively when solving problems.
Mm-hmm.
It's like having a tool in your toolbox that you've never learned how to use.
So it's like knowing the Pythagorean theorem, but not knowing how to apply it to find the length of a hypotenuse in a real-world problem.
Exactly.
It's useless.
Schoenfeld argues that traditional math instruction often focuses on teaching inert knowledge.
Mm-hmm.
Students might be able to recite formulas or definitions,
Right?
but they struggle to apply those concepts to solve problems.
Okay.
Active knowledge, on the other hand, is knowledge that we can readily access and use in a variety of contexts.
Okay.
It's flexible, adaptable, and readily available when we need it.
So it's like having a well-worn tool in your toolbox that you can use instinctively and confidently, even in new and unexpected situations.
That's a great way to put it.
Yeah.
And Schoenfeld emphasizes that teachers should strive to help students develop active knowledge.
Okay.
This means focusing on conceptual understanding,
Mm-hmm.
providing opportunities for students to apply our knowledge in meaningful contexts,
Right.
and encouraging them to make connections between different concepts and ideas.
So it's not just about memorizing facts and formulas.
No.
It's about building those deep connections, those networks of understanding that allow students to use their knowledge flexibly and creatively.
Precisely, and this brings us back to the importance of practice.
Okay.
Schoenfeld argues that practice is essential for transforming inert knowledge into active knowledge.
Right.
But it's not just about mindless repetition.
Okay.
It's about engaging in deliberate and purposeful practice that challenges us to think deeply and develop our skills.
So it's not about doing worksheets filled with the same type of problem over and over again.
Exactly.
It's about tackling problems that require us to stretch our abilities,
Right.
to apply our knowledge in new ways, and to engage in that productive struggle that leads to deeper learning.
And it's about reflection on that practice, analyzing what worked, what didn't, and how we can improve.
This is making me think about the importance of providing students with feedback
Yeah.
that focuses on their thinking processes, not just their answers. It's not enough to just tell them if they got the problem right or wrong.
Right.
We need to help them understand why,
Exactly.
to analyze their strategies, and to identify areas for improvement.
It's about helping students develop that metacognitive awareness that allows them to become more independent and self-directed learners.
This is all so fascinating. I feel like I'm seeing math education in a whole new light.
I feel the same way. Schoenfeld's work offers such a rich and nuanced perspective on learning and problem solving.
Yeah?
It's not about quick fixes or easy answers.
Right.
It's about understanding the complex interplay of cognitive, metacognitive, and affective factors,
Mm-hmm.
and then creating learning experiences that nurture and support all of those aspects.
And it's about empowering students to see themselves as capable, confident, and joyful problem solvers, ready to tackle the challenges of the world around them.
Absolutely.
Now, you've mentioned that Schoenfeld's framework emphasizes control as a major stumbling block for students. Can you elaborate on that a bit more?
Absolutely. Remember, control is all about managing and regulating our own problem-solving process.
Okay.
It's about planning our approach,
Right.
monitoring our progress, and being willing to adjust our strategy if needed.
Okay.
But Schoenfeld found that even students with strong resources and knowledge of heuristics often struggled because their control was weak. They'd jump into a problem without a plan, get lost in the weeds, or give up too easily when they hit a snag.
Okay.
They lacked that metacognitive awareness to guide their actions.
It's like trying to build a house without a blueprint or a foreman.
Exactly.
You might have all the materials, but without a plan and someone to oversee the process, things are likely to go awry.
Exactly, and that's where teachers come in.
Okay.
We can play a crucial role in helping students develop better control over their problem-solving processes. One way is to encourage students to plan their approach before diving into a problem.
Okay.
This might involve asking themselves questions like,
Okay.
what information do I need? What strategies might be helpful? Or what are the potential pitfalls I need to watch out for?
It's like taking a moment to assess the terrain before embarking on a hike.
Exactly.
You want to have a general sense of where you're going and what challenges you might encounter.
Another strategy is to encourage students to monitor their progress as they work. This involves regularly checking their work, asking themselves if their approach is making sense,
Right.
and being willing to adjust their strategy if needed.
It's like checking your map periodically to make sure you're still on the right path.
Exactly.
If you find you've veered off course, you need to be willing to recalculate and find a new route.
And finally, teachers can help students develop better control by encouraging them to reflect on their problem-solving processes after they've finished a problem.
Okay.
This might involve asking themselves questions like,
Okay.
what worked well? what didn't work so well, or what would I do differently next time?
It's like conducting a post-hike analysis.
Exactly.
You want to learn from your experience so you can be even more prepared for your next adventure.
By developing better control over their problem-solving processes, students can become more efficient, effective, and confident learners.
And what's fascinating is that Schoenfeld found that control is not just a cognitive skill.
Right.
It's also influenced by those belief systems we talked about earlier.
Exactly. If a student believes that math problems should be solved quickly and easily,
Right.
they might be less likely to engage in planning, monitoring, and evaluation. They might view those metacognitive processes as unnecessary or even as a sign of weakness.
So it's not just about teaching students how to control their thinking. It's also about helping them develop beliefs that support and encourage those control processes.
Absolutely. Students who believe that effort and perseverance are key to mathematical success are more likely to embrace those metacognitive strategies.
Yeah.
They see those strategies as valuable tools that can help them overcome challenges and achieve their goals.
It all comes back to creating that growth mindset.
Yeah.
Now, as we wrap up this part of our deep dive, I think it's worth emphasizing the power of Schoenfeld's framework.
Absolutely.
It gives us this incredible lens for understanding the complexities of mathematical problem solving. But it also goes beyond math, right?
Yes.
These ideas can be applied to any subject, to any challenge we face in life.
Absolutely. It's about developing those critical thinking skills, that metacognitive awareness, that growth mindset. Those are essential for success in any field.
And it's about remembering that learning is a journey, not a destination.
Yes.
It's about embracing the struggle, the mistakes, the moments of confusion. Those are all part of the process.
Beautifully put.
So as we move into the next part of our deep dive, let's keep this framework in mind and see how it plays out in some of Schoenfeld's fascinating case studies.
Yeah.
I have a feeling we're going to gain even more insights into the art and science of problem solving.
I'm excited to delve deeper. You know, one of the things that makes Schoenfeld's work so compelling is how he brings these abstract concepts to life through real-life examples.
Right.
His case studies aren't just data points.
Yeah.
They're stories about real students grappling with real challenges.
It's like peeking into the minds of learners and seeing how those gears are turning.
Right.
Or sometimes why they're getting jammed.
Yeah.
So which case study jumps out at you?
Well, there's one about a student named David, a college sophomore in a problem-solving seminar. He was bright, had a solid math background. But there was a pattern to his struggles.
What was he doing?
Schoenfeld noticed that David would jump into a problem without taking the time to truly understand it. Or consider different approaches. He'd try one thing, and if it didn't work instantly, he'd leap to something else without analyzing why the first attempt failed. It was all about speed, a bit chaotic, really.
So his control wasn't so great.
Exactly.
It's like he had all the hiking gear,
yeah,
but was just scrambling up the mountain whether checking the map or the terrain.
Exactly. And Schoenfeld dug deeper and found that David's belief system played a big role. He believed that good mathematicians solve things quickly, almost magically.
Right.
He valued finding the right approach over carefully analyzing the problem or exploring options.
So his belief about what it means to be good at math was actually tripping him up.
Yeah.
Like he thought the best hikers just intuitively knew the way.
Yeah.
And if he had to stop and think he was doing it wrong.
That's a great analogy. So Schoenfeld worked with David to slow down, really understand the problem. And consider different strategies before diving in.
Right.
He introduced David to heuristics, like drawing diagrams or working backward, giving him more tools for that mental toolbox.
And I'm guessing this wasn't just about teaching techniques, but also shifting David's mindset?
You got it.
Okay.
As David started using these strategies, he started to see problem solving as a process of discovery, not a race.
Okay.
He even started questioning that belief about speed equaling ability.
So it was a two-pronged approach, giving him the skills and helping him reframe his beliefs about what it means to be a successful learner.
Exactly. And the results were remarkable.
Oh, wow.
David became more patient, more persistent, and ultimately more successful at solving those challenging problems.
It shows that understanding Schoenfeld's framework isn't just theoretical.
Right.
It has practical implications for how we teach and learn.
I agree.
This is really inspiring.
Yeah.
It gives me so much hope for students who might be struggling because they've internalized those negative beliefs about themselves
Right.
or about what math should do.
Yeah, that's the beauty of Schoenfeld's work. It shows us that change is possible.
Okay.
Now, zooming out a bit, it's important to see how his research has impacted the field of math education as a whole.
Okay, so what kind of ripple effect has his work had?
It's been huge.
Okay.
First, he really put the spotlight on metacognition,
Okay.
that ability to think about your own thinking.
Right.
His research showed that successful problem solvers are like skilled navigators, constantly monitoring their progress and making adjustments.
So they're not just blindly following steps, they're thinking strategically about what they're doing and why.
Exactly, and this led to a shift in math education.
Okay.
Now many teachers emphasize metacognitive strategies,
Okay.
teaching students to ask themselves questions like, is this approach working? Do I need to change course? It's about making those thought processes explicit.
Which ties in perfectly with Schoenfeld's idea of making thinking visible, right?
Yes.
Students need to see those metacognitive moves modeled, not just told they should do them.
Another huge impact has been on how we understand belief systems. Schoenfeld showed us that what students believe about math, about themselves as learners,
Right.
it all influences their actions and their success.
It's not just about what's in their backpacks, the resources. It's about the mindset they bring to the hike.
Exactly, and this has led teachers to focus on creating supportive learning environments,
Right.
emphasizing effort over innate ability, and showing that math can be engaging and meaningful.
Right.
It's about cultivating those positive beliefs.
It makes me think about how some students might disengage because they've decided they're not math people.
Yeah.
But if we can shift those beliefs, who knows what they could achieve?
And finally, Schoenfeld's work has led to a focus on creating learning environments that truly foster problem-solving expertise. He argued for giving students opportunities to tackle authentic problems, work collaboratively, and get feedback on their thinking, not just their answers.
So less about rote memorization and more about creating a space where students can explore, make mistakes,
Right.
and really grapple with challenging ideas.
That's the heart of it.
Yeah.
It's about creating a culture of inquiry and exploration, where learning is seen as an active, engaging process.
You know, it strikes me that Schoenfeld wasn't just a researcher. He was also a teacher.
Right.
He really put his ideas into practice, right?
Absolutely. He and his colleagues developed a problem-solving curriculum called Habits of Mind, which focuses on everything we've been talking about.
Right.
Metacognitive skills, strategic thinking, positive dispositions towards problem-solving.
It's like taking all those theoretical insights and translating them into actionable classroom strategies.
Exactly.
What's the curriculum like?
Well, it's built around flexible problem-solving guidelines. Encouraging students to understand the problem, plan their approach, carry out that plan, and then reflect on what worked.
Right.
But it's not just about individual work.
Okay.
It emphasizes collaboration and communication, too.
So students are working together, sharing their ideas, learning from each other's approaches.
Exactly.
It sounds like a much more dynamic and social way to learn math.
Exactly. The teacher becomes a facilitator, guiding discussions and encouraging reflection.
Right.
And studies have shown that this approach really works. Students' problem-solving skills, their metacognitive abilities, and even their attitudes towards math improve.
It's so encouraging to see that these ideas can be put into practice.
Yeah.
And that they make a real difference in students' lives.
It's a testament to Schoenfeld's vision and his dedication to improving math education.
Absolutely.
Now, shifting gears a bit, I think it's important to acknowledge that not everyone listening is a math teacher.
Right.
Or even a student.
Right.
What do Schoenfeld's insights mean for the rest of us? Out in the real world.
That's a great question. I mean, we don't all face equations every day.
Right.
But we do face problems, right?
Exactly. Schoenfeld's work reminds us that problem solving is a fundamental human skill, something we use constantly.
Right.
Whether we're trying to figure out a better commute, navigate a disagreement, or plan a big project.
So those four elements, resources, heuristics control, and belief systems, they're relevant to any challenge we face.
Yes.
Not just math problems.
Absolutely. Thinking about our resources in a situation.
Okay.
The knowledge and skills we can bring to bear. Considering different heuristics.
Right.
Those strategies we can use.
Yeah.
Practicing control. That ability to plan, monitor, and adjust our approach.
Right.
And maybe most importantly, examining our belief systems. Are we approaching the challenge with confidence and a growth mindset?
It's like he's giving us a framework for tackling any problem more effectively.
Yeah.
Instead of just reacting emotionally or getting overwhelmed, we can step back and say, okay, what are my resources here? What strategies can I try? And what beliefs might be holding me back?
And that shift in perspective can be incredibly powerful.
Right.
It allows us to move from feeling stuck or helpless to feeling empowered and capable.
It's like he's giving us a new set of lenses through which to view the world.
Yeah.
And those lenses can help us see problems as opportunities for growth and learning.
Exactly.
And not just obstacles to overcome.
That's a great way to put it. Schoenfeld's work reminds us that we're all lifelong learners, and that learning itself is a problem-solving process.
It's like we're all students in the school of life.
I love that.
And Schoenfeld is our wise and insightful professor guiding us on our learning journey.
And one of the most important lessons he teaches us is the power of belief systems.
Right.
They can be incredibly powerful, shaping not only how we see ourselves, but also how we approach challenges and ultimately what we achieve.
So if we believe we're not math people, that belief can actually limit our mathematical abilities?
Exactly. It can make us avoid challenges, give up
Right.
easily, and ultimately fulfill our own negative prophecy.
Right.
And it's not just about math. If we believe we're not creative or not good with technology,
Right.
those beliefs can become self-fulfilling as well.
It's like we build these mental cages for ourselves,
Yeah.
limiting our own potential. But the good news is we can break out of those cages.
Absolutely. Schoenfeld's work shows us that beliefs can be changed.
Okay.
It takes effort, reflection,
Mm-hmm.
and sometimes even a bit of courage.
Yeah.
But it's possible to shift those limiting beliefs and embrace a more empowering mindset.
So it's about recognizing those negative beliefs, challenging them, and then consciously choosing to adapt more positive and productive beliefs.
It's like upgrading our mental software, installing those beliefs that will support us on our learning journey.
And it's a journey that never really ends, right?
No.
We're constantly learning, evolving, and adapting to new challenges.
Exactly, and that's what makes life so exciting.
Now, you mentioned earlier the importance of teachers modeling their own problem-solving processes.
Yeah.
I think this is such a crucial aspect of Schoenfeld's work.
Absolutely.
It's not enough to just tell students what to do.
Right.
We need to show them how we do it,
Yes.
warts and all.
It's like the old saying, don't tell me, show me.
Yeah.
Students learn so much from observing how we approach problems, how we grapple with challenges, how we make mistakes and learn from them.
Exactly. And it's not about pretending to be perfect
Right.
or always having all the answers.
Yeah.
It's about being authentic,
Mm-hmm.
about showing students that struggling is a normal part of the process,
Yes.
that even experts make mistakes, and that it's okay to ask for help.
It's about humanizing the learning process and creating a space where students feel safe to be vulnerable,
Right.
to take risks, and to embrace the messiness of learning.
That's a beautiful way to put it. And it all comes back to creating that growth mindset,
Right.
that belief that our abilities are not fixed,
Mm-hmm.
but can be developed through effort practice and a willingness to learn from our experiences.
You know, it strikes me that this idea of modeling problem solving is not just for teachers.
Right.
It's for anyone who's in a position of mentorship or leadership.
That's a great point. Whether you're a parent, a coach, a manager, or even just a friend,
Yeah.
showing others how you approach challenges,
Mm-hmm.
how you think through problems, can be incredibly powerful.
Right.
It's about sharing your process, your struggles, your triumphs,
Yeah.
and inviting others to learn alongside you,
It's about creating a culture of shared learning and growth,
right?
where everyone feels supported and empowered to take risks, make mistakes, and stretch their abilities.
Exactly. Now, speaking of stretching our abilities,
Yeah.
one of the things that Schoenfeld emphasizes is the importance of deliberate practice.
Yes.
It's not just about doing more math problems.
Right.
It's about engaging in practice that is purposeful, challenging,
Mm-hmm.
and focused on specific goals.
That's right. And this applies to any skill we want to develop, not just math.
Right.
Whether you're learning to play an instrument,
Yeah.
write code, or speak a new language, deliberate practice is essential.
So what does deliberate practice look like in the context of math?
Well, first, it's important to identify specific areas where you want to improve.
Okay.
Maybe you struggle with word problems.
Right.
Or maybe you need to brush up on your algebra skills.
Okay.
Once you've identified your goals,
Yeah.
you can then choose practice problems that target those specific areas.
So it's about being strategic in our approach to practice.
Right.
Not just blindly doing whatever problems we come across.
Exactly. And it's also important to challenge ourselves, to push beyond our comfort zones,
Right.
and tackle problems that are just a little bit beyond our current abilities.
This reminds me of the concept of flow that we've talked about before. That sweet spot where we're engaged, challenged, but not overwhelmed.
Yes.
Deliberate practice should push us towards that flow state.
Absolutely. And it's also crucial to get feedback on our practice.
Right.
This might involve working with a teacher, a tutor,
Yeah.
or even just a friend who can help us identify areas where we need to improve
Right.
and offer suggestions for alternative approaches.
It's like having a coach who can observe our performance, point out our blind spots, and help us fine-tune our technique.
And finally, it's important to reflect on our practice, to analyze what worked, what didn't, and how we can continue to improve.
It's about taking that growth mindset
Yes.
and applying it to our practice, seeing every challenge as an opportunity to learn and grow.
Exactly. And by engaging in deliberate practice,
Yeah.
we can gradually transform our inert knowledge into active knowledge, developing the fluency and flexibility we need to become truly proficient problem solvers.
Now, as we're wrapping up this part of our deep dive, I want to touch on something we haven't explicitly discussed yet,
Okay.
but that's woven throughout Schoenfeld's work. The role of intuition and creativity in problem solving.
Ah, yes. It's so easy to think about math as being all about logic and rules.
Right.
But Schoenfeld reminds us that intuition and creativity are just as important.
Yeah.
Especially when we're tackling those really challenging problems.
So it's not just about following a set of steps. It's about those flashes of insight, those moments of inspiration that can lead us to breakthroughs.
Exactly. Intuition in the context of problem solving is that gut feeling that guides us toward a possible solution.
Right.
Even if we can't fully articulate why,
Right.
it often comes from our past experiences.
Yeah.
Our subconscious processing of information, those patterns was observed, but maybe haven't consciously acknowledged.
It's like that moment when a hiker suddenly senses the right path, even though there's no clear trail marker.
Yes.
It's based on experience, on a deep understanding of the terrain, even if they can't explain it logically.
That's a great analogy. And then creativity, it's that ability to generate new ideas. See connections that others might miss, think outside the box.
Right.
It's what allows us to approach a problem from a fresh perspective and come up with a novel solution.
So it's like that hiker who, instead of getting discouraged by a fallen tree blocking the path, decides to climb over it,
Yeah.
build a makeshift bridge, or even find a whole new route.
Yeah.
They're not limited by the traditional ways of doing things.
Exactly. And often intuition and creativity work together.
Okay.
Intuition might give us a starting point, a hunch to explore.
Right.
And then creativity allows us to develop that hunch, to play with different possibilities,
Okay.
to shape it into a workable solution.
It makes me think of those ha moments when the pieces suddenly fall into place.
Yeah.
And you see the solution in a whole new way. It feels almost magical. But Schoenfeld is saying that we can actually cultivate those moments.
Absolutely. We can nurture our intuition and creativity by exposing ourselves to a wide range of mathematical ideas, by playing with concepts, by allowing ourselves to make mistakes.
Right. And by collaborating with others. So it's about fostering a mindset of curiosity, playfulness, and openness to new ideas.
Yes.
It's about seeing math not as a rigid set of rules,
Right.
but as a world of possibilities waiting to be explored.
That's the spirit. Schoenfeld reminds us that mathematical problem solving is not just about logic and reason. It's also about imagination and inspiration.
Right?
It's about embracing the joy of discovery and the thrill of finding elegant solutions.
You know, it strikes me that this idea of intuition and creativity is particularly relevant in today's world, where we're facing particularly complex and unpredictable challenges.
Yeah.
The ability to think flexibly, to adapt to new situations, to come up with innovative solutions.
Right.
Those are essential skills for navigating the 21st century.
I completely agree. Schoenfeld's work, while rooted in mathematics,
Yeah.
has profound implications for how we approach any challenge.
Right.
Whether it's personal, professional, or global. It's about developing those habits of mind, those ways of thinking that allow us to not just solve problems, but to thrive in a world of constant change and complexity.
It's about empowering ourselves to become lifelong learners.
Yes.
Capable of adapting to new situations, generating creative solutions, and making a positive impact on the world around us.
Now, as we move towards the final part of our deep dive, I'm curious to hear what specific insights resonate most with you.
There's so much to unpack here.
Right.
But one thing that keeps coming back to me is the power of belief systems.
Yeah.
It's so easy to underestimate how much our beliefs, those often unconscious assumptions, can influence our actions and ultimately our outcomes.
Absolutely. And it's not just about those big overarching beliefs about ourselves. It's also about the smaller, more subtle beliefs that we might not even be aware of.
Okay.
Like the belief that math problems should be solvable quickly,
Mm-hmm.
or that there's only one right way to do things.
Those beliefs can act like invisible barriers holding us back from exploring new possibilities,
Yeah.
taking risks and stretching our abilities.
And what's fascinating is that these beliefs are often formed through our experiences,
Right.
especially our early experiences in school.
Mm-hmm.
If we were repeatedly told that we weren't good at math,
Right.
or if we struggled in a particular math class,
Yeah.
those experiences can shape our beliefs about our mathematical abilities for years to come.
It's like those negative experiences leave these mental scars that can be hard to heal.
But the good news is beliefs can be changed.
Okay.
It takes effort, reflection,
Mm-hmm.
and sometimes even a bit of courage. But it's possible to reframe those negative beliefs and embrace a more empowering mindset.
So it's not about erasing our past experiences.
Yeah,
It's about consciously choosing to adopt new beliefs that are more aligned with our goals and aspirations.
exactly. It's about taking ownership of our belief systems and recognizing that we have the power to choose the thoughts and beliefs that will shape our lives.
One of the things I appreciate about Schoenfeld's work is that it doesn't offer any quick fixes or magic formulas.
Right.
He acknowledges the complexity of the learning process, the interplay of all these different factors,
Yeah.
and he encourages us to approach learning with a sense of curiosity, humility, and a willingness to experiment.
I agree. There's no one-size-fits-all approach to problem solving or learning.
Right.
What works for one person might not work for another,
Right.
and what works in one situation might not work in another.
So it's about being adaptable, resourceful, and open to new ideas and approaches.
Mm-hmm.
It's about becoming lifelong learners who are constantly seeking to expand our understanding and refine our skills.
Beautifully put now. As we transition to the final part of our deep dive, I'm eager to hear your thoughts on one of the most powerful
Okay.
and perhaps most challenging aspects of Schoenfeld's framework,
Mm-hmm.
the role of emotions in problem solving.
It's so easy to think of math as being purely logical and objective,
Right.
but Schoenfeld reminds us that emotions play a huge role in how we approach and experience math,
Yeah,
just like they do in every other area of our life.
exactly. And those emotions can either support our learning or hinder it.
Right.
Think about how anxiety can create that brain freeze feeling during a test,
Yeah.
even if you know the material cold,
Right.
or how frustration can lead to impulsive decisions and careless mistakes.
Like those negative emotions hijack our thinking, making it hard to focus, access our knowledge, and apply our skills effectively.
And on the other hand, positive emotions like
Yeah.
curiosity, excitement, and even joy
Right.
can actually boost our motivation, enhance our creativity, and help us persevere through challenges.
So it's not just about managing those negative emotions.
Right.
It's also about cultivating those positive emotions that fuel our learning and problem solving.
That's right. And this is where teachers can play a crucial role
Oh,
by creating a supportive and encouraging learning environment,
mm-hmm.
by presenting math in engaging and meaningful ways,
Right.
and by helping students develop strategies for managing their emotions.
Yeah.
We can create a space where students feel safe to explore, to take risks,
Mm-hmm.
and to embrace the messiness of learning.
It's about nurturing not just students' minds, but also their hearts.
Beautiful said. And it's not just about the classroom.
Right.
We can all apply these insights to our own lives,
Mm-hmm.
recognizing the power of emotions in our own learning and problem solving,
Right.
and consciously choosing to cultivate those emotions that support our growth and well-being.
This has been such an illuminating conversation.
Yeah,
I feel like I'm seeing math learning and even life itself through a new lens.
I feel the same way. Schoenfeld's work offers such a rich tapestry of insights, and I'm excited to delve into the final part of our deep dive, where we'll explore some of his most thought-provoking ideas about the nature of learning and the power of belief systems.
Okay, as we wrap up our deep dive into Schoenfeld's work, it feels like we've unpacked a whole toolkit for becoming better thinkers,
Yeah.
not just in math class, but in life.
It's amazing how these ideas, while rooted in math, have these broader ripples.
Totally, one thing I'm still mulling over is that even if Schoenfeld wrote this back in 1985,
Right.
it feels so relevant to how we teach and learn today, especially with all the talk about 21st century skills and mindsets.
That's what makes it a classic, right? Those
Yeah.
fundamental insights about how humans learn, they don't go out of style.
Right.
And speaking of things that haven't changed much,
Yeah.
there's always been debate about the role of technology in math education. Calculators, computers, now AI.
Right.
It's easy to wonder if we even need those old school skills anymore.
Right. Why memorize timetables when your phone could do it instantly?
Right.
But Schoenfeld, even back then, had some interesting thoughts on this.
He was ahead of his time in a lot of ways.
Yeah.
He saw technology not as a replacement for thinking,
Right.
but as a potential enhancer I have to use strategically.
Okay, so it's not about ditching the pencil and paper entirely.
Right.
But about figuring out how tech can help us understand concepts better.
Yes.
Or tackle more complex problems.
Exactly. Think about graphing calculators. Instead of spending tons of time plotting points by hand,
Yeah.
students can visualize functions, see patterns, experiment with different parameters. It deepens their understanding in a way that's hard to do manually.
It's like we're not getting rid of the hiking boots,
Yeah.
but we're giving students a powerful map and compass to navigate that mathematical terrain more effectively.
Love that analogy.
Yeah.
And it's not just calculators, computer simulations, modeling tools, even online resources like interactive tutorials. They can all bring math to life in ways that weren't possible before.
But there's a catch, right?
Yeah.
Schoenfeld didn't think we should just throw tech at the students and call it a day.
He was very clear about that.
Yeah.
Technology should enhance human thinking, not replace it.
Okay.
Students still need that foundation of basic skills and concepts.
Right.
We have to teach them how to use these tools effectively to understand their limitations and to critically evaluate the results they get.
So it's like giving a student a fancy new piece of hiking gear,
Exactly.
but also giving them the training and knowledge to use it safely and effectively, right?
Exactly. It's about empowering students to be thoughtful, discerning users of technology,
Yeah.
not just passive consumers of information.
Right.
And that, I think, ties back to one of Schoenfeld's core messages.
Okay.
It's not just about what you know, but how you think.
Which brings us to the topic of perseverance.
Yes.
It feels like this is woven throughout Schoenfeld's work,
Yeah.
even if it's not explicitly one of those 4 framework elements.
Right.
He observed that successful problem solvers don't just give up when things get tough.
It's such a crucial point, especially in math, where frustration is practically a given.
Right.
Schoenfeld saw that those who succeed, they're willing to struggle, to try different approaches, to keep pushing even when the answer isn't immediately obvious.
It's that grit, that stamina,
Yeah.
that's almost as important as the knowledge itself.
Absolutely. And it's something we can nurture in students.
Okay.
Creating a classroom culture where effort is valued,
Right.
where mistakes are seen as part of learning, where it's okay to ask for help.
It makes me think about how often we praise students for being smart or getting the right answer quickly.
Yeah.
But maybe we should be praising their resilience, their willingness to stick with a tough problem.
Yes.
Those moments when they don't give up, even though it's frustrating.
I love that shift in focus.
Yeah,
It's
right.
about praising the process, not just the product.
Right?
And that can make a huge difference in how students see themselves as learners.
Totally. If I believe that my success depends on being naturally good at something,
Right.
then struggling just means I'm not good enough.
Yeah.
But if I believe that effort and perseverance are key, then struggling becomes a sign that I'm learning and growing.
Exactly. And that shift in mindset can make all the difference.
Right.
It's about seeing challenges not as roadblocks, but as opportunities to build those mental muscles.
Okay, so as we bring our deep dive to a close, I want to bring it back to our listeners,
Okay.
to the teachers, students, parents, anyone who's been on this journey with us.
Yeah.
What are some key takeaways they can walk away with?
Wow, there's so much.
I know, right?
But if I had to pick a few,
Okay.
first, remember that learning is an active process. It's not about passively absorbing information. It's about engaging, questioning, experimenting.
Right.
It's about making thinking visible,
Yeah.
both in ourselves and in our students.
And that ties in beautifully with the second takeaway.
Yeah,
Metacognition is key.
absolutely.
That ability to reflect on how we're learning, what's working, what not. Those are skills we can all develop and strengthen.
And we can't forget the power of belief systems.
Right.
Those underlying beliefs about ourselves and our abilities,
Yeah.
they can either be our biggest allies or our toughest obstacles.
Yeah.
So it's worth taking the time to examine those beliefs,
Right.
to challenge the ones that aren't serving us,
Mm-hmm.
and to cultivate those that empower us to grow.
I love that it's like Schoenfeld is giving us permission to not only be good at math, but to believe we can be good. And that belief itself can fuel our success.
Absolutely. And lastly, I'd say remember that learning is a journey, not a destination.
Okay.
There will be bumps along the way, moments of frustration, maybe even times when we want to give up,
Right.
but it's those challenges that ultimately make the journey worthwhile.
It's like their feeling of reaching the summit after a tough climb.
Exactly.
You don't just magically appear at the top. You have to put in the effort,
Yeah.
navigate the obstacles, and keep going, even when it's hard.
And that sense of accomplishment, that growth you experience along the way,
Right.
that's what makes it all so rewarding.
So as we wrap up our deep dive into Alan Schoenfeld's incredible work, let's all carry these insights with us.
Yes.
Whether we're teaching, learning, or simply navigating the challenges of everyday life, let's remember to be curious, to be persistent, and to never stop believing in our own capacity to learn and grow.
Beautifully said. And who knows, maybe along the way we'll even discover the joy of mathematical exploration.
Until next time, happy problem solving, everyone.
To T119.